We'll come back to yesterday's class. We were discussing about continental drift theory. So, are you clear with the continental drift theory? Yes. Let us quickly revise. The continental drift theory is given by Wegener, 1912, tectonic geography, continental drift theory, Mantle convectional cells, and plate tectonics theory. Right? Apart from that, I have to tell you the concept of sea floor spreading theory. Harry Hess. Continental drift theory, Mantle convectional cell theory, and plate tectonics theory. It is not given by one single person, multiple people are there in this. Right? So one needs to have an idea on all of these aspects. We are done with the continental drift theory. I told you that the continents are drifting from one place to another place. This is given by Alfred Wegener in the year 1912. And post that, he said that the continents are drifting and they are moving westwards, towards westwards. He has changed his position twice. Once he said that the continents are moving towards the poles, and again he said that the continents are moving towards the equator. He has multiple opinions on every aspect, but the explanations which he gave, that was false. But whatever evidences he gave, they were true. And he gave 5 evidences. The first one is jigsaw fitting. That is South America and Africa, North America and Europe. For that, he used Caledonian Mountains and Hercynian Mountains. Right? Next, second evidence is that fossils. In that, he used 4 fossils: Cynoganthus, Glossopetris, Lystrosaurus, and Mesosaurus. Mesosaurus, Lystrosaurus, Cynoganthus, and Glossopetris. Glossopetris is a flowering plant. Right? Now, he used 4 fossils. Next, it is placer deposits. Now, what are placer deposits? The source will be somewhere, but the deposits will be elsewhere. The source of the gold placer deposits, it was present in South America, but the placer deposits, he found it in Africa, across the Ghana coast. Next is tillate deposits. Now, what are tillate deposits? When glacier moves, it leaves evidences. Now, those finer particles, if you look into, you will understand that how come the glacier deposits or tillate deposits are found in the southern part of India, that too in Tamil Nadu and in the Deccan. So it was very surprising to him. It is because, especially the Tamil Nadu hills are considered to be one of the oldest hills. Okay? They are very, very old. In India, Indian geography, when you learn that Deccan Plateau and all, they came later. India में सबसे पुराना landmass, the oldest landmass of India is the peninsular India. Okay? It is peninsular India. Wherever you hear the word shields, they are the oldest landforms. Right? So, these tillate deposits are also found in Tamil Nadu, southern parts of India and rest of the places. This is tillate deposits. And the other evidence is, yes, these are the 5 major evidences. Right? And another evidence is there. That evidence I will tell you after what is geomagnetism. Okay? If that is nothing but drifting poles. He also used the evidence of drifting poles. If I teach you about drifting poles, I don't think you will understand it now. Drifting poles means, see, Earth has 2 poles. One magnetic pole, other one is geographic pole. So in the starting lectures, I told you that magnetic poles and the geographic poles. See, magnetic poles are those poles where the magnetic angle which is there, that makes 90 degrees with the Earth. And you also have geographic poles. Geographic poles are the places where the Earth rotates on its axis. Okay? See, look at this. I'm not giving you a concept now. I'm only introducing the words. What is magnetic pole and what is geographic pole? See, geographic north is a north which is actually the axial line, jahan se axis of the Earth passes through. Apart from that, our Earth also has another north, that is North Pole, that is magnetic North Pole. So he used the magnetic north and the magnetic south poles to use it as evidence that our continents are drifting. Now this concept I'll explain after the geomagnetism. ठीक है? For that you need to know what is geomagnetism. अब again a brief introduction here. See, a small homework for you. घर जाके ये check करना. Our magnetic north poles are moving how many kilometers in an year? If this is your Earth, this is North Pole, and this is South Pole. This is magnetic North, and this is magnetic South. Now this magnetic South, it can keep on changing its positions. For some time it can be here, and for some time it can be here. Every year, this pole is shifting its position by 50 kilometers on an average. Since 2020, if you look into till 1900s, our the geographic North Pole, this magnetic North Pole used to be here, and it has drifted till this distance. That means in the last 30 years, the drifting was high. Right? Now, why this drifting takes place, you will be able to understand after I teach the Mantle convectional cell theory, plate tectonics theory, and also some concepts about the interior of the Earth. Right? Now, the next theory that I have to explain is Mantle convectional cell theory. Right? So look at this Mantle convectional cell theory. This concept is based on the concept of differential heating. Differential heating of the interior of the Earth. Right? Now, what do you mean by differential heating? It is nothing but at various layers, which are present in the interior of the Earth, they have different densities and different temperatures. So this different densities and different temperatures which are there, just a minute. See, as you go into the interior of the Earth, I told you what are the layers they are present. From now on, we have to understand with respect to asthenosphere, only on the mechanical composition we are going to study. You know there are plates, and these plates are present only on the lithosphere. So the topmost layer is your lithosphere, then followed by asthenosphere, then followed by mesospheric mantle, outer core, and inner core. So this is your asthenosphere, right? And this asthenosphere, I told you, it has a shape. Yes, according to the weight, it keeps on changing. The lithospheric depth, it depends upon what kind of material is present, right? So here, what is the density of these materials? Are they increasing or decreasing towards the as you go into the interior? Here, plus temperature increases with depth. See, for suppose this is outer core, which is liquid in nature, right? And this liquid, it has radioactive material. Okay? There are radioactive materials which are present in the interior of the earth. Now, why this radioactivity is there? It is because since the origin and evolution of the earth, the materials are experiencing such high temperatures, and at that temperatures, radioactivity is naturally present. Core, not just in the core, in the mantle also there can be radioactivity. Okay? There can also be, in the core also there can be radioactivity. Radioactivity in simple terms is like a material like nuclear material. It is like hundreds and hundreds or thousands or lakhs and lakhs of bomb blasts that are taking place within the interior of the earth. Right? At times, what happens is that if I take this diagram, sometimes what happens within the interior of the earth is there can be radioactive material which can be present here, and this radioactive material at times it can shift its position, or at times this radioactive material can shrink in its size. Okay? There are possibilities. Now how that happens, I'll explain in another half an hour or so. Earth, within the interior of the earth, you have radioactive material, right? Now, to show it little practically, let me show you the same Mantle convectional cell theory video. Look at this. As you go into the interior of the earth, our earth has various layers, right? Look here. Just imagine this is the core. Okay? And from here, if there is radioactive material that is present here, if radioactive material is there, it will be too hot, extremely hot, and it is bursting out. When bursting out, some kind of changes will take place, right? Now from here, there will be rise of the magma that takes place. Now this magma, as and when it starts to rise, will it not reduce its temperature? Because with respect to height, the temperature is reducing. Now as soon as it reaches near to the lithosphere, the temperatures become very cold. If it is extremely hot, what happens? They puncture and they come out in the form of volcano. Okay? Right? Volcano can also be formed like this, and this type of volcanoes, they are called as hotspot volcano. Okay? This type of volcanoes are called as hotspot volcano. Now first thing what I said is that near to the core, especially to the outer core, there are extreme radioactive materials which are present in the lower part of the mantle. Now because of these radioactive materials, the concentration can be high sometimes it can be low. Wherever you find the highest concentration of the radioactive materials, from there the material starts to rise. Now this rising material, it will get cooler. As soon as it reaches near to the crust, it is extremely cold, and then it will start to diverge in either sides. While it is diverging, imagine there is crust here. Just imagine this is crust, right? And this crust, see, if this material is moving in the either sides, don't you think there will be friction that will be present between the lithosphere and the mantle convectional cell? Right? Sometimes what happens is that, imagine this is also a lithospheric plate. Okay? Look here. So, this lithospheric plate will move along with the mantle convectional cell. What is this rising limb? Isn't it a rising limb? The mantle convectional cell is rising. Now, whenever there is rising that is taking place, Same like low pressure system which we have studied. When the temperature is hot, here the temperature is extremely hot, the rising will start to take place. Now once the rising starts, it reaches near to the surface of the earth, that is near to the crust or lithosphere, they will start to tear apart this particular crust. Just imagine, maybe earlier your crust would have been like this. This is the crust. Okay? But because of the rising material or limb, what does it do is, it can have the potential to tear apart. It can tear apart your lithosphere, and then here you will see a rift valley. ठीक है? यहाँ crust कमजोर होता है, and then land gets separated, and you can see the volcano coming out. Got it? Now, why is this plate moving? The friction between the rising limb and then the material which is moving on either wards. This creates a friction and it moves. Now with what speed it moves? It depends on how the temperature, what is the concentration of temperature that is present here, what is the concentration of radioactive material that is present here. Now just imagine the radioactive concentration which is present here, it has come down. Today only less radioactive material is present. Then this cell will be moving very slowly. Okay? So this is what is taking place within the interior of the earth. Now first let's see a small video, you'll get a complete picture here. Look here, outer core pe chal raha hai ye sab. This is where the outer core, the material is starting to rise up. Sometimes this can happen in the outer core, sometimes it can happen in the mantle, it can be happening anywhere. But majorly it happens at the boundary of the outer core and the mantle. Boundary of the outer core and the mantle. Differential heating of the interior of the earth. Now what I have written? Differential heating of the interior of the earth. That means the layers near to the surface are cooler as comparatively, and the layers near to the interior, that is outer core, it is more warmer. That's the reason why the cells, the mantle convectional cells starts to form. Like this, that material which has risen, it separates the continental crust or oceanic crust. Right? It can be like this. In this manner, there is rising limb rises and then it diverges, then sinking limb sinks, again it comes back to the same area. Like this, it forms one full convectional cell. Okay? This is what is mantle convectional cell. Now in a broad view, you got to understand this, but now let me give you a complete picture how it takes place. See here. Imagine this is inner core, and you know that inner core is a solid body. Right? Outer core, now is it what? It is right? I told you there can be radioactive materials that can be present here. Imagine that there is higher concentration of radioactive materials which are present here. Don't you think the temperature at this place is more as compared to the temperature at this place? Yes? So here the rising starts. Now this rising starts like this. Imagine right? In between you also have mantle. Okay? In between you also have asthenosphere. It punctures the asthenosphere. And asthenosphere is like which kind of material? It is a semi-molten plastic pillow kind of material, molten in nature. So see, for your understanding, what I'll do is, this is what is lithosphere. On the lithosphere, you can sometimes see mountains here. You can see an ocean. Maybe there can be a plateau. Likewise, you can have multiple landforms which are there on the surface. Now, his question is, sir, is radioactive material always present at the outer core? No. It can be present in the mantle also. It can be present near to the crust as well. It can be present anywhere. Right? But here, for our understanding, I am telling you that radioactive material usually, many of the times, not all the time, many of the times, it will be present near to the outer core and mantle boundary, like this. Now, this concentration is more. Right? So, let's imagine it has punctured through all the other layers. Just let's imagine it has punctured through all the other layers, and then as and when it starts to rise, once it reaches, it will cool down. ठीक है? यहाँ पे टेम्परेचर क्या है? 5000 डिग्री सेल्सियस. यहाँ पे टेम्परेचर it can be 200, 300, 400 degrees Celsius. Now, as soon as it cools down, it will start to diverge. Now it diverges and it cools down, and then what does it do? It will start to sink back. Because hot materials will rise and cool materials, by the time they have reached to this surface, their density might have reduced, and then it will start to sink. The sinking happens like this. Now, where is this sinking happens? The sinking happens at a place where the temperature is less. For example, the temperature is very less at this particular place as compared to this. Right? The yellow dots are radioactive material, and here you do not have any radioactive material. So, from here on, you will see the sinking limb. And like this. So rising limb, and you will have so what do you get to see here? ये तो एक convectional cell बन गया. This is called one full convectional cell. What is the primary reason? The primary reason is differential heating of the interior of the earth. That is because of the radioactive materials that are present. And why this radioactive material? Please be patient for another half an hour. You will get to know. So here onwards, this divergence will take place. Now wherever there is divergence, you will see maybe this part of the region can be a continent. Okay? Maybe this is a continent. Let's imagine this can be a continent. ठीक है? ये continent हो सकता है. This part of the region can also be a continent. Right? What happens? Continent is separating apart. तो बीच में क्या होगा? Volcanoes. From here, the material will start to come out. I'll make it. ठीक है, ये surface मान के चलो. From here, you will see the volcanoes are present in this manner, right? That means there is divergence taking place. I'll play the video again. You just have a look here. Look. Rising limb. That means here, what do you see? The material flows outward like this. They are volcanoes. Now, in such a conditions, what do you see is the continents get rifted apart, and this rifting apart will be called as Rift Valley. Rift Valley. Okay, it is called as Rift Valley, volcanic Rift Valley. Do you find any rift valleys across the earth? Which one? कॉन्टिनेंट के बारे में बात कर रहा हूँ. दिस इज ऑल्सो ए कॉन्टिनेंट, दिस इज ऑल्सो ए कॉन्टिनेंट. आई एम आस्किंग, इज देयर एनी सच ए काइंड ऑफ लिम्ब? लैंड पे, आई एम टॉकिंग अबाउट लैंड. अफ्रीका. सी, टुडे this is your Africa. So literally, if you look into Africa, this part of Africa is actually getting separated. ठीक है? To be more specific, I'll draw it here. See, here what's happening is that from beneath the surface of the earth, Africa is getting separated into two parts. Tomorrow, your Africa will have this shape. Look here. Your new Africa will be this. This is how your Africa looks. Right? This is what is Rift Valley. There's a beach ka gap. Earlier, today Africa looks like this, right? But because of this Rift Valleys, there is rising limb and it has divided this entire earth. So you will get to see the Africa getting separated into two parts. Now, when Africa got separated into two parts, what happens to Africa? In between, what do you see? In between, you will find oceans. Let me show it to you. Yes, very good question. And where are continents floating? Asthenosphere के ऊपर. ठीक है? That means your continents will be moving here and there on the asthenosphere. Asthenosphere is a pillow, and can you see these lakes? 1, 2, like this. Your Africa is getting rifted across the Nile Valley, near to the Nile Valley. See, in the future, your Africa will get separated like this. This is called the Great Rift Valley. Now, when you go to Africa, you will find volcanoes across this belt. That means this is a new landmass or a new continent which is in the making. Tomorrow, this will move in this direction, and this entire Africa is going to move in this direction. Why? Because of the differential heating of the interior of the earth, and this is a plate, this is also a plate. These plates are getting diverged. Yes. Shaurya says, sir, यहाँ पे जो life forms होंगे वो भी destroy हो सकता है? हाँ, ज़रूर हो सकता है. See, I'll show you an image. This is the reality of African Rift Valley. The rift that you are getting to see today, here, the continents which are there, they are getting separated apart. The volcanoes are moving and coming out faster. It is not a continuous volcanic activity. It can sometimes be faster, it can sometimes be slower, but at the end, there will be one or the other activity that you can get to see here. Right? So this is one of the example where you get to see the two continents are getting separated. Likewise, now you got to learn that in this manner, our entire earth has some kind of concentrations. Maybe you see here the concentration of the radioactive material can be more. Right? If the concentration of the radioactive material can be more here, now you will again see the rising limb here. Am I correct? Rising is happening, and this rising limb will start to diverge. Divergence is taking place, and then from here you will again find the sinking limb. Again, there could be a Yes, you are right, Shaurya. वही हो रहा है. So can you imagine this? How many different convectional cells are there here? That means our entire Earth is made up of convectional cells. Now, if this is one convectional cell, you will call this part of the area as a plate. This is another plate. Maybe plate 1. This is second plate. This can be your third plate. This part of the area where the convectional cell is there, it is plate 3. Likewise, your Earth is made up of multiple plates. Got it? Are you able to understand, or any kind of issues are there? I'll explain all of this. Now, his question is that, sir, how did Pangea form when these many convectional cells are there? Now try to imagine this in 3-dimensional. Can there be a possibility where all this convectional, the higher concentration of the radioactive material can be present at one place? It could be. But Wegener don't know about all of these things, no? Wegener only knows that these plates are moving. What did he study? He went and studied an animal here. Okay? He went and studied another animal here. He went and studied maybe the mountains that are formed here. Right? This is what Wegener studied. Wegener don't know about all of these things. This theory came little later. Okay? Ab, let's try to understand this. See here. Can you say that each one of this is a plate? Now let's consider that I'll point a location. Let's call this as point A. Okay? Let's call this as point A. See here. This is point A, and this is one plate, and this is also another plate. Right? Are these plates moving away from each other or pushing against each other? They are pushing towards each other. Why? Dekho, I'll exaggerate this diagram. Imagine this is one plate and this is another plate. Okay? And here I'll call this as China. I'll call this as Indian plate or Eurasian plate. See, can you look into the direction here? Mantle convectional cell flow. The mantle convectional cell flow's direction is like this. What is happening here? Convergence. Here, convergence. What is happening here? I'll call this as point B. What do you get to see here? Convergence or divergence? Right? Again, look here. I'll call this as point C. Convergence or divergence? Now, why is this convergence? Look here. Mantle convectional cells, both are moving in this direction. That means both the plates which are present on the surface, they converge with each other. In this manner, you will see the entire Earth, the plates which are there on the surface of the Earth, either they converge or they diverge. Right? Now, in this manner, you'll have convergence and divergence. Now, where do you have convergence and where do you have divergence? This depends upon that rising limb. And this is sinking limb. आप देख के बताओ, where is the concentration of the radioactive material more? Is it at the base of the rising limb or is it at the sinking limb? At the base of the rising limb. ठीक है? That means radioactive material and the temperatures are extremely high at the base of the rising limb, and most of the times this base of the rising limb will be present at the boundary of mantle and outer core. Okay? At the base of mantle and outer core. And see, this inner core is also rotating all time. Inner core is also rotating. Now this mantle convectional cells will start from the base. Sometimes they are present in the outer core also. In the outer core also, it depends on what is the depth. From the outer core, this is starting. And in this manner, the entire Earth's convectional cells are rotating. At one place, if it is sinking, another place it is rising. Rising and sinking, rising and sinking. Some changes which are happening in the interior of the Earth, they are bringing certain kinds of changes. Now, for suppose you see plate, Chinese plate. This is one plate. No, the directional movement of this plate is one. It is pushing against each other. Imagine this is a continent. And also imagine this is also a continent. Right? Let's also look here. Is this diverging or converging? Converging. Now, for suppose, let's imagine that one of this plate here is ocean, what happens? Okay, and do you remember I told you in the beginning that the oceanic crust density is higher and continental crust density is lower? If suppose this is ocean is colliding with the continent, here actually the ocean sinks. It is like this. If suppose one of my hand which I am using, this is continent and this is ocean. They are getting pushed against each other. Here, when they are getting pushed against each other, one of the limb, this is ocean which is more denser, it will sink like this. Right? That means you will get to see that one of the limb which is ocean, I'll make this continent red color. This continent is in red color and this ocean I'll make it as blue color. Okay? Now just imagine what am I doing is I'm pushing this ocean towards the continent. Here what happens is that my ocean plate will go it goes and sinks under the continent and it gets melted into the mantle. Yes. Sea level में आ सकता है, but the rate at which the faster sinking is happening इतना fast नहीं है, ठीक है? It is not too fast. It is moving at 4 centimeters per year, 3 centimeters per year, but still there can be a changes in the sea level also. So did you get to understand what I told? As and when you start to move them more and more towards each other, you will get to see that one of the limb is getting sinked. ये sinking limb ही है ना? Right? In this manner, if they both are colliding with each other, you will get to see the formation of mountains also and trenches also. ठीक है? Is there a plate like this? There is one ocean and there is a continent. Yes. Where do you find it? Look here. This is continent, and here you have an ocean plate. This is an oceanic plate. This oceanic plate is moving, the surface of the ocean is moving in this direction, and the continental plate is also moving in this direction. What happens? Trenches will also be there. I did not explain you trenches, but I told you there can be a formation of mountains. Now, which plate will go beneath? Which one will sink? This is ocean plate, and the name of this plate is Nazca. Okay? This ocean plate name is Nazca plate. Likewise, this continent which is there, the size of the plate is like this. Right? Here, you will get to see the mountains formed on the continent. And the name of these mountains is Andes. You can open your atlas and look into. Okay? Andes Mountains. The South America. Got it? Mantle के ऊपर होगा. Now, do you remember I told you the older oceanic floor density can be more than asthenosphere. The older oceanic floor's density can be more than asthenosphere, right? See. Now, this is how you will get to see the moving of the interior of the earth. And likewise, I have to tell you something here. See, I am zooming it in what is exactly happening at the convergence of a continent and an ocean. Okay? Mantle convectional cell is nothing but there is a rising limb and there is a sinking limb. Sinking limb will lead to the convergence. Rising limb will lead to divergence. Now, why is this happening? It is because of the differential heating of the interior of the earth. Now, why you have this differential heating of the interior of the earth? It is because of the concentration of the radioactive materials. Right? Now, I wanted to tell you one more process which is happening at this juncture. Okay? Can I explain this? Now, I am also entering into the plate tectonics. I will be explaining you the concept of plate tectonics and the mantle convectional cell theory together. So, can I call this as a continental plate? Can I call this as an oceanic plate? Do you agree? Let's try to understand the concept of continent and ocean, what exactly is happening here. Or else, what I am doing is, I am taking this part of the area and I am also taking this part of the area. You can also look practically. Okay? Or else, I'll show you how the plate looks as well. Couple of days back, I've shown you the map of the plates. Look here. In your atlas also, you'll have a plate tectonics map. You can have a look there as well. Ocean condition, I'll come. Okay. First, let's learn continent and an ocean. Do you agree? Okay. This is South America is a continent and this is an ocean. And see here, there can be a plate which can also have an ocean in this part. Look here, this is an ocean. Right? This is your ocean. That means a plate can have both continent and an ocean, but the convergence here is happening. It is happening between the ocean and continent, right? Here, there is divergence. See, look here. This is also a plate, African plate, right? But in the African plate, what's happening here is this plate is moving towards Nazca plate. That means if this plate is moving towards each other, then there is divergence, right? There is divergence that is at the ocean. That means there can be divergence on one side, there can be convergence on the other side. This is how the entire earth is made up of. Now I am explaining you the conditions of the continent and ocean. Let's see. What is the thickness of the oceanic plate? Thickness of the oceanic crust. Bus. What is the thickness of the continent? Yes? It ranges, crust I am talking, not lithosphere. I am talking about crust. The crust of the continent can be 30 to 80, 90, 100. At Himalayas, it has 100 kilometers depth. Lithosphere can go up to 200 kilometers. But I am only talking about crust. So, destruction of the crust. How is it happening? Let's try to see. What is this area? This is made up of water. Are you able to understand this? What I have drawn? I have drawn the same conditions that you get to see on the board. This is ocean, this is continent, and I am just showing you from the cross-sectional view. Imagine that you are standing here and looking at this particular diagram. So, what's happening beneath the convectional cell? What's happening in the convectional cell? Is it rising or sinking? चलो ये भी देख लेते. I am explaining you ocean and continent. What's happening? Sinking. Let's see. Your ocean is also moving in this direction and your continent is also moving in this direction. Why they are moving? Am I correct? This is a cell that's happening. So let's try to go and see what's there here. If I'm pushing this entire continent towards the, entire ocean towards the continent, whose density is higher? Ocean. Now from here, the density of the ocean is more. Now this particular plate will start to sink. What do you have beneath the crust or the lithosphere? Asthenosphere. Asthenosphere is a semi-molten layer. It can get punctured easily. Yes, it is very, very weak layer. What do you mean by weak? It is like this. Let's consider this is your asthenosphere. And this is your mantle. From here the mantle starts. As soon as there is some kind of melting that is taking place, what is the temperature of the asthenosphere and density of the asthenosphere? Is it more or less? Asthenosphere density, is it more than continental crust or less than continental crust? More than continental crust. That is the reason why your continent is floating on the asthenosphere. But I told you older oceanic floors which are there, they have more density. Okay? Now this oceanic floor, what's happening here is, it started to move like this. Just a minute. Let me draw it in a proper way. See, it started to move further and further downward. जैसे ही नीचे जा रहा है, अब क्या हो रहा है ना? This is getting melted. This particular plate is getting melted. Don't you think the volume of the asthenosphere should increase? If there is melting taking place, don't you think the volume of the asthenosphere should get increased? ये जो blue color plate है, ocean है, it is getting sinked underneath the continent. Continent is also moving in the same direction. So here, the melting of the oceanic plate has taken place. So what happens is that here, this will start to rise. It will puncture. It will puncture the continent, and this punctured magma which is there, the asthenosphere magma which is there, which is punctured, it will start to rise and it will start to form a volcano. Where are volcanoes forming here? This is Andes, and Andes has volcanoes. Okay? Andes has volcanoes, right? Actually, your oceanic plate is going and sinking into the asthenosphere, and sometimes the asthenosphere here, what happens is that there is a process. The process is that, is this crust made up of silica? Silica is there. This is basalt. This is granite. This is silica. Silica इसमें भी है, लेकिन कम percentage में है. 30-40% of silica is there. Now this silica, when it has water with it, मिट्टी को, मिट्टी plus water, when you are sending that, the boiling point of that particular, or the melting point of this rock gets reduced. I'll be repeating it again. There is silica present in this oceanic crust. Right? Do you agree? Silica means, यार ये तो कुछ नहीं है, ये oceanic plate है ना, oceanic crust है, and this oceanic crust के ऊपर मिट्टी होता है ना. This is nothing but a full plate which is getting pushed toward each other because of the mantle convectional cells. Now there is mitti. Along with that, some water can enter into that asthenosphere. Now whenever water plus the silica content mix with each other, the melting point of this rock gets easier. The melting point of the rock gets lower. Earlier, this could have melted at 500 degrees Celsius, but this rock will now start to get melted at 200-300 degrees itself. Okay? This melting which is taking place here, it will slowly start to rise upward. Right? Now this rising limb will come out in the form of volcano. Wherever you have continent and ocean convergence, volcanoes are bound to be present. Volcanoes are bound to be present. Ocean and continent, volcanoes are bound to be present, and mountains are bound to be present. Now, how are the Andes mountains formed? Andes mountain formation is like this. This is continent, and this is your ocean. Right? And can you see this gap which is present here? This is nothing but the deepest part of the ocean. Trench. The deepest part of the ocean is called as trench, and this is present between oceanic crust and continental crust. See, I am pushing this, or I am moving this oceanic crust and continental crust in the opposite direction. Right? Who is stronger? Ocean is stronger. And the continent, when it is getting pushed, the continent's crust gets crumbled. Instead of this shape, what happens is that your continent will start to get folded like this. Why is it getting folded? Because it is getting pushed from the other side. One here it is getting pushed. Right? Because of that, this fold mountains will form. One folding happened. Again, if I fold more, what happens? Or if I am pushing more, mountains का chain बन जाएगा. Height increase होगा. Right? Likewise, these mountains, height increases. Because the crust is getting pushed against each other. In simple terms, take this and I'm pushing against each other. Don't you think it will bend? It will bend. Same is the case. You start to push this crust which is there, you start to push against each other, it is getting folded. Now this is called as crustal folding. This is called as continental crustal folding. And in this mountains, you got to see that the sinking limb, this is sinking limb. This sinking limb of ocean, it is getting melted where? It is getting melted in the asthenosphere and in the mantle. It is getting melted in the asthenosphere and in the mantle. Now why is it getting melted? It is getting melted because its melting point has come down. Now why its melting point has come down? Because silica and water, when they are mixed with each other, its melting point will come down. Earlier, this rock might have melted at a temperature of 500 or 600 degrees Celsius, but now there could be some water that is present in the continental crust. Don't you think that there can be pani in this? There can be present in the continent. Likewise, this 5 kilometers thickness of the plate which is there, this one is 5 to 7 kilometers. इस 5 किलोमीटर की thickness में कहीं ना कहीं पानी हो सकता है. There can be water present like this. You dig a borewell, you get water, right? It can be water present here, water present here. Right? You dig a borewell, you get this water. These are called as aquifers. Yes, aquifers. Aquifers. Groundwater. Aquifers. Now there can be aquifers that can be present in the continental crust and the oceanic crust. Now this water which is there, it gets high pressurized water. Plus mitti is getting melted. Literally mitti hai, rock and plus mitti. And here you will get to see its melting point is lowered and this rock can get easily melted. And this melted materials will now, क्योंकि यहाँ से rise हो रहा है. अब ये mountains which are having volcanoes will be present here. ठीक है? हाँ, जहाँ पे ओशन और कॉन्टिनेंट है 100% माउंटेन्स होगा और उसके साथ वॉल्केनोस भी होगा. Got it? Now I call this as Andes volcanic mountains. And what is the name of this trench? You have Mariana Trench. Likewise, Chile Trench. It's not Mariana Trench, it is Chile Trench. ठीक है? Chile Trench कहाँ जाता है? So, one Chile Trench, Andes Mountains, and this is what is Nazca Plate. Right? Trench is nothing but the deepest layer because the gap between these two is very small and very deep. Now, triangular passage होता है ऐसा. Deepest layer of the ocean. The deepest layer of the ocean or deepest ocean is 9 kilometers, which is present in the Mariana Trench. Yes? Yes. And one more thing, here what happens is that some material will also get accumulated here. Why? Yes, there is pressure that is being experienced here, and some material which is there as the soft material on the ocean that is getting deposited on this part of the area, and sometimes they rise above the surface of the earth, and this rising material which can be present here or which can sometimes be present here, okay? They are called as accretionary wedges when they rise above the surface of the earth. Aquifers में normal water होता है, but when they are getting sink, see, ये aquifer ठंडा ही होता है, but just imagine this aquifer which is there, it has reached here, will it be cool or hot? गर्म हो गया, पानी भी मिल गया, मिट्टी भी है, तो melting point of the rock gets lowered. But now come to the concept of partial melting. Do you remember the concept of partial melting? Chalo. Ab at the end, what is continent? What is this crust? It is nothing but collection of rocks. उनमें से कुछ ऐसा rock होगा जिसका temperature melting point maybe 5000 degrees होगा. Just imagine, let's take a rock from here. 5 kilometers की thickness है, काफी ज़्यादा thickness है. I'll take this rock. ठीक है? I am going to study this rock. See here. I told you rock is nothing but collection of minerals. Here, there can be multiple minerals. Let's call this as A, B, C, D, E part of the rock. A can melt at 200 degrees Celsius. B can melt at 3000 degrees Celsius. C can melt at 500 degrees Celsius. D can melt at 3500 degrees Celsius. And E can melt at 5000 degrees Celsius. अब देखो, ये जो पत्थर है, this rock, imagine, you got this rock to this place. Chalo. You got this rock to this place. Will the entire rock melt? No, it won't melt. Then what happens? Rest of the rock को क्या होगा? नीचे जाएगा. कहाँ तक जाएगा? 5000. Until this rock gets 5000 degrees Celsius, that one of the rock, you will see, it will start to sink from here. Can I say this is the rock? इनमें से एक ऐसा हिस्सा है जो 5000 किलोमीटर्स पे 5000 डिग्री सेल्सियस पर भी बर्न होगा. Now this part of the rock is not getting burnt here. ठीक है? It will sink. It will sink. It will sink. Until and unless it won't get that 5000 degrees Celsius, it won't get melted. It will directly go, the purest material which is there, it will reach to the core. इतना pure है, and it can take that melting rocks. As soon as again it gets melted at 5000, 6000 degrees Celsius, what does it do? It rises. ठीक है? First, this is the rock which has to be get melted at 5000 degrees Celsius. Sinking, 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 it will reach to that 5000 degrees Celsius material. And from there, you will see this material will again starts to rise. That means the material which is there, unka काम ही घूमना. It is the entire earth material which is there. Everything goes through the cycle. Got it? Now this cycle is called mantle convectional cell. The purest form of material which is there, it will go and reach to the core, and the impure materials will be stayed in the knife, that is outer core. Wedges. Accretionary wedges. Now, why does accretionary wedges form? Just imagine this is a plate, and this is also, give me another book, Atlas. Imagine this is an ocean. Okay? This is a continent and this is an ocean. Now just imagine that if I am scraping, ocean मतलब पानी है इसके ऊपर, and then you have some sand also. If suppose I am pushing against each other, ठीक है, I have pushed like this, the material which is there on the ocean, will it not rise? ठीक है, scraping that is happening. Now that scraping which is there, that scraping will lead to the formation of accretionary wedges. तो accretionary wedges में oceanic material होगा या continental material होगा? Dominantly oceanic material will be there, right? And these accretionary wedges, when they rise above the surface of the earth, they can become islands also. ठीक है? So this accretionary wedges, most of the times, they are present here. See, the way I have drawn this diagram, exactly your ocean will not be like this. ठीक है? इतना smooth नहीं होता oceanic continent. It is rough. It can have different shapes. Much of the time, these accretionary wedges are present here. Now this is volcano. This is accretionary wedge. They can be present next to each other. This can be your islands also. Your accretionary wedges can also form here. Scraping की कारण होता है, simple. Right? It can form either places. Now this is what the interaction of the continent and oceanic plate. Right? Likewise, when you look into the plates, there can be oceanic plate, there can be continental plate. There can be a mix of oceanic plate and a continental plate. Broadly, when you look into the global map, you will have major plates and minor plates. Let's see. See here. There is a rift valley which is present here. This is what is African plate. ठीक है? That means, don't you think that African plate has water also? Likewise, this is your South American plate. It also has water. Now direction of these plates are like this. This plate moves in this direction and this plate moves in this direction. Here, this is Pacific plate. Pacific plate is the only plate which is considered to be a major plate, and this major plate is full of oceanic plate. ठीक है? हाँ. So this, here you will have a small plate by the name Nazca, but rest of this is a Pacific plate. It is present like this. ठीक है? You can look into your atlas also. There is a map by the name Plate Tectonics. Now where do you find Indian plate? Indian plate is here. ठीक है? Indian plate is there. So these plates, Indian plate movement is towards this direction. And this is Eurasian plate. The plate's movement, directional movement is like this. Got it? So in this manner, you will see. Now see here. Look at this place. Afghanistan. In Afghanistan, what is the direction of the plate? कुछ अजीब सा है ना. From here, the plate is moving in this direction. And from here, the plate is moving in this direction. Afghanistan यहाँ पर है. Sandwich हो रहा है. ठीक है? It is getting sandwiched. It is actually transform plate कहा जाता है. So if two plates are coming towards each other, this is called convergence. If two plates are moving against each other, this is called divergence. But two plates are scraping against each other like this. They are neither moving against each other nor moving away from each other. Rather, this is called transform. So there can be three different types of plates. One is convergence, other is divergence, and there can be transform plates. Transform boundaries kaha jata hai. So broadly, the first case that we have looked into is the case of an ocean plus continent. Right? Now see, Africa, it is continent, it is also continent. Right? So the plates can be of three different types. Lithospheric plates, they can be of 1. Oceanic plate. Number 2, it can be continental plate. Or 3, it can be a combination of continent plus ocean. Right? Now the interactions of the plates can be of different types. It can be ocean-ocean interaction, it can be continent-continent interaction, it can be ocean-continent interaction. Right? These are three different types of plates. Now, what are the major plates and what are the minor plates? See here. Major plates. Oceanic major plate, it is Pacific plate. I'll explain the concepts of divergence and convergence in each of the plates. Okay? Oceanic major plate is the Pacific plate. So look here. Let me show you the plate first. हाँ, look here. अमेरिका से लेकर रशिया तक. This is North American plate. Major plates I am talking about. North American plate is a combination of continent and ocean. South America continent and ocean. And Africa continent and ocean. Likewise, Indian plate continent and ocean. Australian plate. We call it as oceanic plate, but in between you have continent. Right? Now broadly, the only plate which is fully made up of Pacific, which is fully made up of ocean, is called as Pacific plate. So major plates mein oceanic plate is Pacific plate, but rest of the plates are combinations of ocean and continent. So, but still we call them as continental plates. See, look here, we call them as a continental plate or oceanic plate on the basis of the dominance of the composition. Dominance in the sense, look here, look at this South America. Where is the interaction taking place? On the continent side, right? Okay, this is ocean, this is continent. The interaction is here. North America, this is continent, this is ocean, but the interactions are taking place on the continent. Africa, look here, the major interactions are taking place on the continent side. So that's why we call them as continental plate. So write down the major plates are 1. North American plate, 2. South American plate, North American plate, South American plate, North American plate का ब्रैकेट में लिखो. The Western Atlantic floor, the Western Atlantic floor separated from the Western Atlantic floor separated from the South American plate along the Caribbean islands. The Western Atlantic floor separated from the South American plate along the Caribbean islands. Next, look here, South American plate. This is the second plate. Third one, African plate. Fourth one, Indo-Australia, New Zealand plate. Fourth one, Indo-Australia, New Zealand plate. Indo-Australia, New Zealand plate. Fifth one, this Eurasia and adjacent oceanic plate. Fifth one, Eurasia and adjacent oceanic plate. That is Eurasia and adjacent oceanic plate. This is adjacent oceanic plate. Right? Sixth one, the Antarctic plate. Antarctica and surrounding oceans. This is Antarctica and the surrounding oceans, the southern area. So this Antarctica and surrounding oceans. How many? 6 major plates? Yes? So majorly you have 6 major plates: North America, South America, Africa, Eurasia, Antarctica, and Indo-Australian, New Zealand plate. Yes? We call them as continent because majorly the interactions are on the continent, right? But in fact they are continent plus oceanic plates. Next, minor plates. One, Nazca plate. Look here, this is Nazca plate. Okay? Second one. Here you'll have Cocos plate. COCOS, Cocos plate. Next is Arabian plate, small plate, that one. Arabian plate. And look at Philippines. Philippines plate. Philippines is here. This is what is Philippines. Philippines plate is minor plate. So how many you have written? 4 plus Caroline plate. CAROLINE. Caroline plate. CAROLINE. Caroline plate. Between Philippines and Indian plate. It is a small plate which is present between Philippines and Indian plate. Here you'll have a small Caroline plate. It is not there here. This is one. CAROLINE. You have written Cocos. Next is Juan de Fuca. This is Juan de Fuca plate. Last one, Fuji plate, the where Fuji Island is present. Next, Scotia plate. देखो ऐसे छोटे छोटे 30 प्लेट्स हैं, हर एक प्लेट याद करने की जरूरत नहीं है हमें, बट दीज आर मेजर प्लेट्स, द नेम्स दैट आर गिवन इन एनसीईआरटी दैट यू नीड टू रिमेंबर, right? So majorly the interaction among these plates will lead to the formations of continents, oceans, or the changes that you get to see in the oceans or the changes that you get to see on the continents are primarily because some changes that are happening in the interior of the earth, right? Now this is what is the plate tectonics theory. Here we need to understand the interactions of the plates, right? So let's see. Look here, the interactions can be number 1. It can be an interaction between an oceanic plate and continental plate. Second, it can be ocean with that of ocean. And 3, it can be with that of the continent with continent. Right? We have already discussed one plate, that is oceanic plate with continental plate. In the oceanic and continental plate, the interactions best examples are Nazca is oceanic, and the other one, South America, is continental. And I explained you that this plate sinks. As this plate sinks, there is the melting that takes place, which will lead to the volcanoes with fold mountains. Right? Clear? Now, before I go to the oceanic plate, now this is what is ocean and continental plate interactions. In this particular area, the interaction can be of two different types. One, the interaction can be of convergence and interaction can be of divergence. Look here. This is the case of convergence. There can also be a case of divergence. That means both the plates are moving away. So, first case is continent and ocean convergence. Now let's see ocean and ocean convergence. What happens to the case of ocean convergence? Yes, it is the denser oceanic material will go down. But how will you decide which is denser and which is not denser? Old oceanic floors, but why? Yes? You are true, sediments, but that's not the reason. Why are older oceanic floors more denser as compared to younger oceanic floors? But where do you find the younger oceanic floors? Where do you find them? Near the coast? No. Near the coast you will have older. जहाँ पे volcanic eruptions. Yes, for that first we need to learn divergence. ठीक है? Let's go back and learn about the divergence here. हमने तो ये केस पढ़ लिया, which is convergence, continent and ocean, they are converging against each other. But let's take another case, maybe this as a case. ठीक है? There is rising limb. Do you have convergence or divergence here? Now let's see. This divergence, let's imagine this as ocean. And this is also an ocean. Can it be possible? Yes. There is rising limb, or else simply, ये जो rising limb है ना, you think that this is also ocean, this is also an ocean. Right? That means the ocean is getting rifted apart. Can that be possible in this diagram? Can you identify where this ocean is getting rifted apart? Africa and South American plate. Very good. Can you see this plate? Notice this. Possibility है? है. Now in this case, you see, this is an ocean, this is also an ocean. Ocean, there is divergence taking place. Now what happens here? It is not just ending here. Look here. It is extending into ocean. ये भी तो ocean है ना? This is also ocean. That means all the way from here to, that means the northernmost point of Atlantic to the southernmost point of Atlantic, there is ocean that is present. Right? Now let's try to understand this. So imagine there is a big oceanic plate, and this oceanic plate has water about it. Right? You got to see a rising limb. Right? Now when this rising limb, don't you think it will puncture here? Yes. The puncturing will take place at one or the other point of time, and you see that this rising limb will start to rise outward, and this volcanic materials will start to get deposited. Right? So clear? I'll make it little more easier for you. Can you imagine this? Okay. From here there is rising limb. That means these continents are getting diverged. If they are getting diverged, what is being formed between these two divergences? Yes? Ridges. It is actually, as and when these mountains are getting moving apart, you will see that, this oceanic floor is getting moved apart, you will see the new volcanic material will cool down like this. It will cool in this part of the area. Okay? And once it is cooled, again new material will start to come out. From here, the material will start to come out. It will cool here, and there will be mountains formed here on either sides. After some time, they get pushed away like this. When it is getting pushed away, don't you see that this is getting synced? Continuously, here, the oceanic floor is getting pushed away from each other. Right? And this condition, what do you get to see? Volcanic mountains, and we call this as ridges. Ridges are nothing but oceanic mountains. You call this as, they are present in the middle of the ocean, you call this as middle oceanic ridge. If they are present in the Atlantic Ocean, you call it as Atlantic middle oceanic ridges. Right? Ridges are nothing but the mountain side. So likewise, rising limb will, in the mountains, it will push the continental plates. Now where is the new oceanic floor being formed? Here or here? I'll call this as A. I'll call this as B. Where is the new A? Why B? B is going and getting synced, right? This is getting synced where? ये तो मेल्ट हो रहा है, यहाँ से मेल्ट होकर you will get to see the rising, finally volcanoes are being formed here. Now where is new oceanic floor formed? New oceanic floor is formed at middle oceanic ridges. And the older oceanic floor is formed at? The older oceanic floor is found at trenches. Trenches के आसपास में older oceanic floor will be there, and younger oceanic floors are found next to the middle oceanic ridges. नहीं, see, usually है ना, as and when it rises, the magma also cools down. It will not fall down. Okay? Only the lesser denser material might come up, or it depends on what kind of material it is coming. It comes out very slowly. It does not come out very violently. So let us look into this middle oceanic ridges. Look here. These are your middle oceanic ridges. This is how they look. Right? Now, why are there chain of mountains? If you zoom in and see, there are line of mountains. Plate ka boundary hai, no doubt. See, let's see, this is the boundary of the plate. First mountain chain is formed here. Okay? A volcano erupted, some amount of material is formed on the left side and some amount of the material formed on the right side. After that, plate is also getting moved. Again, new volcanic material will start to come out. That means these chain of mountains, they'll shift their position. These chain of mountains, they'll shift their position like this. This is the plate boundary. Now, earlier the mountains were there, they'll shift their position here. Yes. And then you will see the new chain of mountains which is coming from that volcano. And it can take thousands of years to form them. It can take thousands of years to form them. Which are older, which are younger with respect to color, tell me. Yellow is older and the white is new one. Now the age of this can be 5,000 years and this age can be 1,000 years. Likewise, after 5,000 years, will this yellow be here? Yellow might be present somewhere here. Okay? The yellow will shift its position. In this manner, you will see that here, the chain of mountains which are there, they will also move like this. For example, look here. If suppose in the first case, both of these plates were together. There is a volcanic material which went and rised and it gave mountains. Right? After few thousands of years, what happens? This plate is moving and getting synced here, and this part of the plate is getting melted. Right? Where is the younger oceanic floor being formed? Younger floor is formed at this place, at the middle oceanic ridge. Ye dheere dheere kya hoga? After few years, you will see that these plates move on either sides. Again, the material starts to rise and a new volcanic material will be formed here. Again, after few years, they'll move furthermore and this volcanic material will start to shift its position. Yes, that gap is filling. Now you'll see a new chain of mountains being formed. Right? I hope you now got it. Always the younger oceanic floor is formed at the middle oceanic ridge and the older oceanic floor is formed at the trenches. See here, the younger oceanic floor, is it hotter or colder as compared to the older oceanic floor? Younger is hotter, older is colder. Usually, the colder oceanic floor, weight will be more, density will be more. Younger oceanic floors, heat will be there. It takes little time for itself to cool down and change its structure. The more the cooling, the more the heating, changing of structures will take place. ठीक है, changing of structures might take place. Yes, with cooling rocks, the structure of the rocks can change. Right? So in that manner, when the cooling of the rocks takes place at the trenches, near to the trenches, not at the trenches, beyond trenches again it gets melted, but this is the older oceanic floor, this is the younger oceanic floor. Sometimes the older oceanic floor which is there, its density is more than asthenosphere. Very minimal gap will be there, 3.2 grams, 3.1 grams. That is the difference in density. Older oceanic floor का density ज़्यादा होने के कारण it will go and sink into the asthenosphere. And asthenosphere temperature is more. There, this might have some aquifers, this might have some water. मिट्टी भी है. मिट्टी उसका मेल्टिंग पॉइंट कम हो गया. अर्लियर 500 डिग्रीज पे मेल्ट होना था, अभी 200-300 पे ही मेल्ट होगा. अब वॉल्यूम बढ़ेगा, एस्थेनोस्फीयर का राइज अप होगा, एंड फ्रॉम हियर द वॉल्केनोस राइज and they come out. So this is all a cycle. Something which is happening here is creating an impact here. Right? Likewise, now just imagine what kind of changes can take place on the earth. Yes, wherever you have rising cell, either you'll have the volcanoes coming out, rift valleys हो सकता है. Wherever there is convergence, if it is continent, it can lead to Himalayas. ठीक है, India is a continent and China is also a continent. It can lead to the formation of Himalayas क्योंकि density of this plate and density of this plate both are same. नीचे कोई नहीं जा रहा है, इसीलिए दोनों टकरा के माउंटेन्स बन रहे हैं. Right? Neither one is sinking. But sinking, I'm telling no one is sinking. Sinking in the sense they have to go and melt themselves in the asthenosphere or mantle. But in India, no one is sinking. But they are taking support. For example, this is India, this is Eurasia. India went and hit. India went under this plate. But it is not sinking. It is only beneath. And here, this is Eurasian plate. अब ये जो हिस्सा है, दैट palm of my hand, this is your Tibet. हाँ, Tibet जो है, that Tibet which is there, height is more. So this is the case of India, and all of these things I'll discuss in a very detailed manner. This is just a overview of the topic, and I hope this you got it clear. Now you also got the divergence of ocean and ocean. ओशन डाइवर्जेंस भी समझ में आ गया आपको. ओशन कन्वर्जेंस भी हो सकता है. I'll explain. Yes. Now, one case which you have seen is what are they formed here? Middle oceanic ridges, right? Let's take this case. This is the case of divergence. Now this is the case of convergence. In this case, see, if this is the oldest point, it will go and sink. as compared to this, if this is more older, its density will be more. ये sink करता है, right? The older oceanic floor will sink. Coming to the continent. So in the continent, one, there can be divergence and there can be. कल से अटलस से आना क्लास में. Everyone should have atlas. ठीक है? And those. I would recommend the atlas of Oxford TTK. Can you give that atlas? I recommend this atlas. ठीक है? This is written by one of the IAS. ठीक है? So that this is with respect to UPSC pattern में है. This is what I recommend. So if you do not have this atlas, I am also okay with this atlas. This is Oxford Student Atlas. I want a student atlas, not a school atlas. There's a difference between school atlas and student atlas. जब भी खरीद रहे हो, if you are not getting that atlas, then go for this atlas. Latest edition, whichever is the latest edition. हमेशा क्लास में इस atlas से आना. Right? So coming to the continent, divergence and convergence. See, first let's try to understand the convergence of the continent. This is also a continental plate. This is also a continental plate. Let's understand this is the Eurasia or China. And this is India. What happens in this? If there is convergence. Now in the convergence, at the bottom, what do you see? There might be rising limb here. Clear? This is how the convectional cell is there. Now, in this particular case, number one, both are continents. This is also a continent, this is also a continent. Same density. Neither will go and sink. See, sinking will happen like this. But in this case, there is no sinking. But one of the plate, what happened in the case here is, one of the plate went underneath this plate. And this is taking support over the Indian plate. Did Indian plate sink? No. No sinking. No melting of the Indian plate. But इसका thickness क्या हो गया? Increase हुआ. Right? And here, the more it went inside, the more it took the support. It is, this is how it is. Now look at the thickness of the crust. It has increased. And here, it is not like this. See, if suppose, if I am pushing, this is Indian plate. Okay? If I am crushing this Indian plate or I am pushing this Indian plate, will the structure be same? No. It gets folded like this. For example, let's take this as the Indian plate. And if I am trying to push against each other, converge this plate will change the shape of its structure. It will be right? Next, if I am pushing more, the shape will be like this. Do you agree? Again, if I am pushing more with the other Eurasian plate, or here also you will see the crushing. But you will see that more the crushing, you will and in fact, this is how you will get to see. The size of the plate gets shrinked. Now these became your Himalayas. ठीक है? So look at the width. Width is too high. So this is nothing but a continental plate, and this is also a continental plate. Convergence of the continent and continent will lead to the fold mountains. These are fold mountains. Now what happens to the size of the crust? Will its width increase or decrease? Width increases. Length of the plate decreases. पहले इंडिया का प्लेट साइज बहुत बड़ा था, बट ये धीरे धीरे क्रश होने के कारण और एल्स पुश होने के कारण द साइज ऑफ द इंडियन प्लेट गॉट रिड्यूस्ड. Got it? This is what is continent. And divergence of continent and continent you have already seen in the case of Africa. Right? So broadly, this is what is your plate tectonic. Indian map say, but it will take thousands of years. See, Shaurya says that, sir, when you look into India, then the North India, especially Ladakh and these regions, that means the height of this mountain should increase. Definitely they are increasing. Every year they are increasing because we are pushing against each other. Second, the length of the Indian plate can get reduced. It can get reduced. Also, whatever is melting in the Himalayas, whatever the material that is forming in the Himalayas, there are glaciers melting. Rivers will bring that material which is formed there and get it deposited at the ocean. Sometimes on the oceans, especially near the deltas, new landmass can be formed. Okay? So broadly, this is what is your continental convergence. But I have told you the concept behind it, but I should also tell you in the each and every case with examples. So this is what is your Eurasia, and this is what is your India. Sorry, this is India and this is Eurasia. Whichever way you think. Indian plate is little downward, but there is no sinking taking place. Right? So in this manner, you will see the plates are getting converged, diverged, and there are interactions that are taking place. Ocean convergence हो रहा तो what do you get to see? You will get to see trenches. ठीक है? If suppose there is an oceanic plate that is involved, trenches are bound to form. Ocean with ocean, trenches will be there. Ocean with continent, trenches will be there. ठीक है? Continent, no trenches. Mountains, Himalayas. Right? Ocean, continent, mountains can be formed. Can mountains be formed in ocean continent? Andes, South America. Can volcanoes be there? Can there be volcanoes in the case of continent? Why no? Because there is no melting of the crust that is taking place. So that's why there is no volcanoes. इसीलिए earthquakes can be there in Himalayas, but no volcanoes. Right? Earthquakes can be formed in Himalayas, but not volcanoes. हाँ, अब शौर्या का क्वेश्चन है, सर इस हिमालयास का भी कहीं ना कहीं लिमिट होना चाहिए ऊपर जाने का. आफ्टर दैट व्हाट? दे विल राइज टू अ हाइट बियॉन्ड विच व्हाट? बियॉन्ड विच your Himalayas cannot rise not more than 10,200 meters. Once it is rising, did you remember the concept of that the taller these mountains, the base of this mountain should also be wider? Yes? That means this is the shape of the lithosphere. Imagine the more the taller, it should also have an equal base. ये और tall बन गया. That means its base should also be increased. Now beneath the lithosphere, what layer do you have? Asthenosphere. If the weight is more, asthenosphere gets punctured और नीचे से this gets melted. ठीक है? So that's why the height of the Himalayas cannot go beyond 10,200 meters. Today, 884 8 is the height of the Mount Everest. ठीक है? So it cannot grow not more than another 1200 or 1300 meter, around 2000 meters more it cannot go anymore. 10,200. It gets melted, destabilized हो गया. And this concept, there's a concept called isostasy. ठीक है? Isostasy is जितना ही tall mountains होंगे उतना ही tall मतलब depth पे crust होना चाहिए. ठीक है? There's a concept which will be taught in the optional but not for GS. There's a concept called isostasy. See, why is that oceanic crust very thinner? The plateaus which are there, if you look into plateau will be like this. This is a plateau. But the base of the plateau will also be like this. Yes. Yes, same. So similarly, you will get to see in equal and equal amount pe there is asthenosphere floating that is taking place there. Right? Now this is what is your plate tectonics. But here in the plate tectonics, yesterday I told you that you need to have a short notes, and this short notes should be like this. Look here. I'll give you this. In the plate tectonics, what you need to know is there are plate boundaries which are divergent. See, try to understand the boundaries. Boundaries are of 3 different types. 1, convergent. 2, divergent. 3, transform. Right? Tomorrow we'll discuss all of this in a very, very detail. Each line by line we'll discuss. I'll give you the case studies. I'll give you the diagrams also for this. Divergent plates move apart. Okay? One, it can be ocean. Other one, it can be ocean. Ocean divergence. Best examples? Indian Ocean. ठीक है? Middle oceanic ridges. See, look here. This is what is middle oceanic ridges. What are these mountains? Pacific में भी है oceanic ridge. Likewise, Indian Ocean also you have these ridges. These are some of the examples. Ocean divergence. So look here. Sea floor is spreading. I did not explain what is sea floor spreading theory. Tomorrow I'll explain. This is sea floor spreading theory and middle oceanic ridges. Volcanoes बनता है. Examples, mid-Atlantic and Pacific ridge. Right? Likewise, continent, East African Rift Valley. Now convergent plates, ocean continent, Peru, Chile trench, Andes trench. Ocean, Mariana Trench. Now where is this Mariana Trench is found? So I want you to get tomorrow your atlas and keep open the plate tectonics map. See, this is a plate, Australian plate here. And this is Pacific plate. So can you see? Ocean. Right? Here you will get to see the trench. Now where is Mariana Trench? It is somewhere here. Here. This is Mariana Trench. Can you see literally this plate is different and this plate is different? Yes. अब ये दिख रहा है ना आपको? These lines which are there, these are plate boundaries. Literally from the space also you are able to identify. This is the plate boundary. Now see here. Can you see this? This is one plate. This is Pacific plate. This is Aleutian Islands. So here also there is convergence taking place. These small islands which you get to see the chain of islands. Yes, these are volcanic in nature. These are accretionary wedges. इन्हें कहते हैं volcanic arcs. Yes. आइलैंड बन गया, ये सब वॉल्केनिक आइलैंड्स है. ओशन ओशन कन्वर्जेंस हो गया. सी, look here. If I am turning like this, I'll tell you how these islands are formed. This is oceanic plate. This is also oceanic plate, right? Older oceanic plate जो है, this is older oceanic plate. It is getting sinked. Now when it is getting sinked, what happens? Melting is taking place. That means here there is rising island, mountains. If suppose this ocean is there and these mountains, they are rising above the ocean. These are volcanic islands. Okay, group of islands they can be. Now these volcanic group of islands are this. All the chain you should get to see, they are called as Aleutian Islands. ठीक है? Aleutian Islands. Greenland volcanic eruption is completely different. ठीक है? Greenland में क्या है ना? Are you talking about Greenland or are you talking about Iceland? Iceland. चलो. ये जो Iceland है, you'll be surprised to see that from the center of the Iceland there are plates that are passing through. See. Look at this Iceland. If I zoom in, can you see this line? Iceland is literally having the boundary in the Iceland. So Iceland pe, it is bound to find earthquakes also, it is bound to find volcanoes also. No matter whatever the development you do, it will go into the ground. ठीक है? So plate boundaries, that's why I want you to keep your atlas aside so that you will get to see. And can you see this image? एक छोटा सा line दिख रहा है ना? This line is the boundary. So you'll see this boundary, nothing but the middle oceanic ridge. I'll try to show you. Identify this line. Now this is what is middle oceanic ridge. Give me atlas. Open the page of plate tectonics and give me 98 or 100 somewhere it will be. 118. So see these lines which are represented. ठीक है? For online, page number 118. These lines which are there, they are middle oceanic ridges. So these are some things that you need to know. So tomorrow we'll stop here today, and tomorrow we'll learn in little more detail about the plate tectonics, and I'll wind up the plate tectonics and sea floor spreading. याद करना, कल sea floor spreading करना है, and the plate tectonics completion I have to do, and then we'll go to the basics of oceanography. So we'll complete the basics first, advance में आगे करेंगे, and then I'll switch to the environment, क्योंकि once I'm done with the basics here, I wanted to teach you environment. Environment you will really enjoy. Then again I will come back to the geography, because geography and environment need to be studied together, more or less. And those students who have completed the environment, wonderful. Geography और आसान से समझ में आ जाएगा, and if you want you can attend again. It will be very enlightening to you. Right? Species, continents, drifting, all these aspects you'll get to know. Right? So we'll stop and tomorrow we'll continue. Ocean में? I'll answer. Okay, online we'll stop here. Any doubts in tomorrow's starting of the session, I'll address that. Okay? Why Indian plate is not melting under the subsidence or beneath Munendra? It is because both the plates' density is same. Okay? The density of both the plates is same, that's why. Okay, we'll stop here and tomorrow we'll continue.